Unix is one of those names that you might have heard floating around in tech conversations, but many people still don't fully understand what it actually is. Yet the crazy part is that Unix is everywhere, silently powering so much of the modern world without most people even realizing it. When you start digging into the history of computing, you quickly discover that Unix sits right at the center of almost everything. It's not just an old operating system from the past. It's the foundation that shaped entire generations of technology. If you're using a MacBook, an iPhone, an Android device, a server, a router, or even cloud platforms like Oz, there's a good chance that something inspired by Unix is running behind the scenes, making everything work smoothly. The story of Unix begins decades ago inside Bell Labs, where a group of researchers were experimenting with ways to make computers more efficient, more flexible, and easier to work with. They didn't just create an operating system, they created a philosophy. That philosophy would eventually change the direction of computing forever. Unix developers believed in keeping things simple, direct, and modular. They wanted tools that could be combined like Lego blocks to create more complex solutions whenever needed. This idea sounds basic today, but back then it was revolutionary. Most systems were these giant, messy structures filled with complicated tools that only specialists could understand. Unix came in and said, "Let's make it clean. Let's make it simple. Let's make it elegant." And that elegance became one of its biggest strengths. Instead of massive programs, Unix gave people small commands that did one job extremely well. And by linking those commands together, users could achieve incredibly powerful results. This design was so effective that it spread like wildfire among universities and research labs. Students loved it because it made learning programming, networking, and system design so much easier. Universities adopted Unix for teaching, and a new generation of developers grew up with it. Those developers eventually went on to build the technologies that shape our world today. They created new operating systems, new software, new companies, and new tools, and almost all of them used the principles of Unix as their foundation. To this day, Unix principles show up in places most people never notice. When you open a terminal and type commands, when you use scripts, when you manage servers, when you troubleshoot networks, you're using ideas that come directly from Unix. One of the most unique things about Unix is how everything in the system is treated like a file. Whether it's a piece of text, a device, or a running process, Unix interacts with it the same way. This unification makes the system incredibly consistent and predictable. That consistency is why so many professionals love Unix. Once you understand how it works, you can understand any Unix-based system because the core philosophy remains the same across different versions and generations. Even though Unix started small, it grew into an entire family of operating systems. BSD, Solaris, X, HPUX, MacOS, all of these are children of Unix. And Linux, which powers most of the modern internet, was designed with Unix ideas at its core. When you hear that most servers in the world run Linux, what that really means is that they run something that behaves like Unix. The command structure, the file system layout, the shell environment, they all follow the same principles. This is why so many professionals encourage beginners to learn Unix or Unix-like systems. Once you understand Unix, everything else starts making sense. You gain insight into how computers work from the inside out. Unix isn't flashy. It doesn't try to hide anything behind fancy graphics. Instead, it exposes the real engine, the real structure, and the real commands that make the machine work. That transparency is what makes it so powerful. The Unix shell is another masterpiece of simplicity. At first glance, it's just a blank screen waiting for commands. But once you start typing, you realize it's one of the most flexible tools ever created in computing. Every command, every script, every pipeline lets you control the system with precision. You can take multiple tools, connect them using pipes, and create workflows that solve complex problems in seconds. This ability to combine small tools into larger processes reflects the core Unix philosophy. Don't build huge, complicated programs. Build simple ones that work together beautifully. This approach influenced not just operating systems, but also programming languages and software. Many modern engineering principles like modularity, reusability, and minimalism came from the Unix way of thinking. Another major reason Unix became so influential is its stability. These systems were designed for environments where crashing was simply not an option. Banks, universities, government institutions, and tech companies needed something reliable. Unix delivered reliability better than almost any other system of its time. Its architecture kept things organized, clean, and manageable, reducing errors and preventing chaos in large computing environments. And as the internet began to grow, Unix was right at the center of that revolution. Many early internet protocols and servers were built on Unix because researchers trusted its stability and appreciated its flexibility. Tools like TCP, IP, FTP, SSH, SendMail, and even early web servers were all deeply rooted in the Unix environment. The internet we enjoy today wouldn't exist in its current form without Unix powering those early networks. Another huge breakthrough that came alongside Unix was the C programming language. Created by the same team, they designed C to be flexible, powerful, and portable, and Unix was rewritten in C, making it one of the first systems easily moved between different machines. This decision changed the entire software industry. It made Unix adaptable. It meant companies could run Unix on different hardware platforms. And it made C one of the most influential programming languages ever created. From C came C++, Java, Rust, and other languages that still dominate modern development. And all of them owe a massive amount to Unix's evolution. Unix also paved the way for open source culture. When its code was shared among universities, students and researchers were able to study it, learn from it, and contribute to it. This collaborative environment eventually inspired movements like the creation of Linux and BSD. The BSD family in particular made huge contributions to networking, performance, and system security. Parts of macOS and iOS still use BSD components today, which means your iPhone has Unix DNA running in its core. Because of its strong architecture, Unix excels at multitasking. It allows multiple processes to run smoothly without crashing or interfering with one another. This made it ideal for shared servers and multi-user environments. Long before cloud computing existed, the multi-user design of Unix was far ahead of its time. People could log into a single machine remotely and work as if they were sitting in front of it, long before personal computers became common. This concept became incredibly important once the internet matured and remote servers became the heart of computing. Unix systems already had everything needed to handle multiple users, networks, and complex workloads. Even today, you can log into millions of servers around the world using SSH, a Unix-born tool, and feel instantly at home because the environment is familiar, predictable, and powerful. One of Unix's biggest strengths is its file permission system. It's simple, built on basic read, write, and execute flags. Yet it's powerful enough to secure large environments, which is why it remains a standard even decades later. This security model contributed to Unix's reputation as a trustworthy system, especially for servers and enterprise environments. Companies handling sensitive data relied heavily on Unix systems for stability and protection. Unix's impact on networking is equally massive. From early internet stacks to modern cloud infrastructures, Unix systems form the backbone of digital communication. Routers, switches, firewalls, and even embedded systems often run Unix-like software. This makes Unix one of the most important technologies in the entire networking world, especially because it's so efficient at handling connections, protocols, and data streams. One thing that separates Unix from other systems is how deeply it encourages user control. Unlike systems that hide complexity, Unix invites you to see how everything works. It gives you tools to inspect processes, monitor performance, view logs, modify configurations, and automate tasks. This openness is what makes Unix a favorite among developers and system administrators. It transforms you from a passive user into someone who can actually command the system and understand its behavior. Unix also encourages experimentation. You're free to try things, write scripts, create tools, and build workflows that reflect your style of working. That freedom is incredibly empowering, which is why Unix users often become passionate about it. As time passed, Unix evolved into different branches. Some became commercial systems used in enterprises like Solaris and AIX. Others stayed open and community-driven, like the BSD family. And Linux emerged as a vibrant ecosystem built on Unix principles. But even with all these branches, the core Unix philosophy stayed the same everywhere. Keep it simple. Keep it clear. Keep it modular. Let tools do one job well. Let users connect them to create bigger solutions. This consistency is one of the reasons Unix is still relevant today. Technology has changed dramatically, but Unix principles remain timeless. They work just as well in a 1970s mainframe as they do in a 2025 cloud server. Unix systems are also known for their ability to run for months or years without restarting. Their stability makes them ideal for critical workloads like databases, scientific research, telecommunications, and e-commerce. When you see uptime records showing servers running for 500 days, 800 days, or even longer, those machines are often Unix or Unix-like systems quietly doing their job without interruptions. Unix also provided generations of developers with their first true taste of programming logic. Many computer science students wrote their first programs, compiled their first code, and executed their first algorithms on Unix systems. Because Unix was widely adopted in universities, it shaped the habits and mindsets of early programmers. This influence later spread into businesses and software companies, many of which hired developers who had grown up with Unix. Another important part of Unix culture is documentation. The man pages, short for manual, provide detailed explanations for almost every command and tool in the system. This built-in documentation became a trademark of Unix. Man pages empowered users to learn at their own pace, experiment freely, and understand the system deeply. Even today, developers rely on man pages as a trusted source of technical information. Unix also introduced tools that became legendary in the computing world. Commands like grep, awk, st, and cut are incredibly powerful text processing utilities still used by developers and sysadmins every day. These tools might look simple, but they can manipulate massive amounts of text with incredible speed and precision. They are the backbone of many automation tasks and data processing pipelines. Pipes, represented by the symbol, are another genius idea from Unix. By connecting commands together, you can turn small tools into complex workflows without writing entire programs. This idea influenced scripting languages, big data systems, and software engineering practices. These features made Unix ideal for automation. With shell scripts, users could turn repetitive tasks into automated processes that ran flawlessly. Automation became a part of Unix culture long before DevOps existed. Unix also influenced hardware design. Companies built machines specifically optimized for Unix workloads, which pushed innovation in performance, memory management, and reliability. Systems like Sun Microsystems' SPARC machines and IBM's Power systems were engineered to run Unix better than anything else. These machines powered scientific research, financial institutions, and global enterprises. As computing shifted toward virtual machines and containers, Unix-like systems adapted seamlessly. Docker containers, Kubernetes clusters, and cloud platforms all rely heavily on Unix principles to manage processes, file systems, and networking. In modern cloud environments, Unix is everywhere. Whether it's Oz EC2 instances running Linux, Google's massive data centers powered by Unix-like kernels, or MacOS used by developers, the spirit of Unix dominates the industry. And yet, despite all that influence, most casual users don't even realize how important Unix is. It's the silent giant of computing, always working, always supporting, always powering what we rely on. Unix didn't just survive decades of change, it thrived. It adapted to new hardware, new programming languages, new paradigms, and new technologies. That adaptability is rare and speaks to the intelligence of its original design. When you peel back the layers of modern systems, you often find familiar Unix patterns. The directory structures, the configuration files, the user management, the process control. They're all based on Unix ideas that have stood the test of time. The truth is, Unix never went away. It simply transformed into different shapes, living on through MacOS, Linux, BSD, and dozens of other systems. Even if you think you're not using Unix, chances are you're using something derived from it. This continuity is part of what makes Unix so special. It's a living piece of computing history that continues to evolve and influence everything around us. Even the smartphones billions of people hold in their hands are powered by Unix-like kernels. iPhones run a certified Unix operating system under the hood, and Android uses a modified Linux kernel, which inherits Unix behavior. This means Unix touches everyone, even if they don't realize it. It's quietly powering communication, entertainment, navigation, social media, finance, and work. When you look at the security world, you'll also find Unix everywhere. Penetration testers, cybersecurity analysts, and forensic experts rely heavily on Unix tools because they offer visibility, control, and power. Tools like NMEP, tstump, Netcat, and Wireshark all have Unix roots. These tools gave professionals the ability to inspect networks, analyze packets, and secure systems long before cybersecurity became a mainstream field. Unix's permission system, multi-user structure, and process isolation laid the foundation for modern security models. Even advanced systems like Selinux, Aparmer, and sandboxing techniques borrow ideas from Unix. Another thing that keeps Unix relevant is its supportive community. Users share scripts, create tutorials, develop open source tools, and maintain a culture of learning. This community-driven approach helped Unix stay modern and competitive. Because Unix is transparent and open, users can modify their systems with a level of control that closed systems rarely allow. This freedom attracts passionate developers who continue improving the ecosystem. The simplicity and beauty of Unix also influence new generations of programmers. Many beginners start with Linux or MacOS and learn command line basics that follow the same rules that were established decades ago. Understanding Unix gives you an advantage because it opens doors to many other technologies: DevOps, cybersecurity, cloud computing, AI engineering, networking. All of these fields rely heavily on Unix-like systems. And as the demand for skilled tech professionals grows, knowing Unix or Linux becomes a powerful asset. It's one of those rare skills that remains valuable no matter how much the industry changes. Unix also shaped how software is packaged and delivered. Early package management systems, ports trees, and repositories came from Unix environments. These ideas evolved into modern tools used in Linux distributions, MacOS, and even Windows today. Another powerful idea from Unix is treating text as a universal interface. Instead of relying on complicated formats, Unix tools often communicate using simple, human-readable text streams. This makes debugging, automation, and chaining tools incredibly easy. This practice influenced command line interfaces, APIs, configuration files, and even modern programming conventions. The idea that everything is text became a cornerstone of good design. One thing that sets Unix apart is how easy it is to learn a little but grow a lot. You can start with basic commands, then slowly build into scripting, automation, networking, and system administration. Each skill builds on the same simple foundations. Unix rewards curiosity and exploration. Every time you learn something new in Unix, it opens another door. And the deeper you go, the more powerful you become as a developer or system administrator. What makes Unix truly remarkable is that even after 50 years, it still feels modern. The system hasn't become outdated or obsolete. Instead, the world evolved toward the ideas that Unix introduced long ago. You could take someone who learned Unix in the 1970s and sit them in front of a modern MacOS or Linux system, and they would instantly recognize much of the environment. That level of consistency is extremely rare in tech. The longevity of Unix proves just how strong its philosophy is. Technologies change fast, but principles like simplicity, modularity, and efficiency never fade. Unix's influence continues to expand as new industries emerge. AI workloads run on Unix-like systems. Cloud systems rely on them. Networking equipment depends on them. Even modern gaming servers often use Linux, a Unix-inspired system. The story of Unix is the story of modern computing, a tale of innovation, collaboration, and enduring design. It shaped the past, defines the present, and continues to guide the future. Understanding Unix means understanding the engine behind the digital world. It gives you insight into how everything works beneath the surface, from apps to servers to networks. Unix teaches you how to think like a builder, how to solve problems with clarity, and how to design systems that last. It gives you a foundation that strengthens everything else you learn in technology. So when someone asks, "What is Unix?" the real answer is that it's the silent force behind the internet, the foundation of modern operating systems, and the philosophy that shaped the digital age. Unix is the system that taught computers how to be organized, efficient, and powerful. It's the tool that empowered generations of developers. And it's the quiet giant still holding the digital world together today. It may not always be visible, but it's always there, running behind the scenes, powering servers, securing networks, supporting apps, and helping the world stay connected. Unix isn't just an operating system. It's a legacy, a mindset, a foundation, and a blueprint for modern computing. And even after half a century, its influence is stronger than ever.